Welcome to the Databricks Skill Builder series. We're glad you're here.
Okay, so today we are going to deep dive into the streaming checkpoint, like what is our internals and how it is behaving, and what could be the edge scenarios, and if there is any best practices, we'll be getting to know on that aspect. So about myself, Vikas Reddy, I'm working as a backline engineer, and my areas of streaming, Delta, and Spark SQL. So the agenda is we'll be going through the internals of streaming checkpoint, and with respect to Kafka source to file sync, and with respect to Kafka source to Delta sync, we'll be understanding how fault tolerance is and working with respect to this streaming checkpoint. Next, there will be a couple of Kafka performance improvement options will be discussed. And finally, we'll be discussing on one edge case with respect to the checkpoint. Okay. So internals of streaming checkpoint. So what is a role of the streaming checkpoint? So let's say when you start the application, streaming application, as a first step, it will be fetching a metadata from the source. Metadata is just a data of data, right? So it will be there in the source. From that, it will be fetching, and that information will be stored in write ahead log. So this write ahead log, it's like a file. We'll be going through more in next slides. So it will be part of a checkpoint folder. Now, based on whatever the metadata, which is part of this write ahead log, will be fetching the actual data. And after fetching the actual data, we will be processing the data. If there is any stateful information, will be processed as per that. And finally, we'll be writing the data to the sink. This is at a high level. And after writing to the sink, then that information along with a stateful information, we'll be writing the data to the checkpoint. It means like a committing the data to the checkpoint. Again, whatever the data it goes to commit, it's like a metadata information. And if with respect to the stateful information, that also goes to checkpoint, that is the actual data. So 3 steps we have to remember. Step 1, it's a fetching the metadata from the source and keeping it to the write ahead log. Step 2, fetching the actual data and processing the data. And step 3, after completion of whole process committing to the destination, we'll be writing the metadata information to the checkpoint. So now let's go a little deeper in the checkpoint folder. Inside the checkpoint folder, there are different folders. So this is a source. Sources is one folder. Under this sources, there will be a couple of metadata. And with respect to the offsets, whatever we discussed here, write ahead log, that write ahead log is nothing but offsets folder here. Under this offsets folder, we'll be storing the write ahead log files. And commits folder. After completion of the entire processing, writing to the data to the destination, we are committing the files, right? So that metadata goes to commit folder. And this is a state folder. This contains information about stateful operations data. And finally, one more file will be there along with 4 folders. This file contains the metadata information of the particular stream. Let's go through. Okay, so this is a classroom setup. If you're executing this, then whatever the required things will be arranged for this setup. Now let's go through a sample example. So I'm just cleaning a few files, creating a directory. And so I hope you guys are aware of how streaming works, right? So we are fetching the data for fetching the data, we're using read stream, and the format is JSON format. The data format is JSON format, so we are going with this. And schema is data schema we are adding here, and yeah, we are doing small word count processing, applying word count logic for this. And finally, we are writing the data. Okay, and this is a checkpoint. Okay, now when it goes to the mean batches to return. So inside this is a streaming application. It's a continuously running. So there can be n number of streams, right? So, but how many batches we actually retain in the checkpoint? It's by default, it's 100 batches will be retained in the checkpoint. Now, when it goes to checkpoint, whatever we discussed, there are 4 folders, right? Commits, offset sources. So let's go each and every one. So this is a commit folder. Currently, there is no data is loaded. There is no data in the source. So commits, we don't see any information. Metadata, this is a ID of a stream. So when you look at here, this is when you start the stream, there will be ID, right? This ID is unique across all these restarts. But in each and every restart, this run ID will change. But ID will be constant across all the restarts. This information goes to the metadata folder, metadata file. Okay. Now let's say with the same checkpoint, if you're restarting, if some other application is going with the same checkpoint path, then immediately it will identify that there is already metadata, and if it is active, that information will be shown. So that is actually use of this metadata file to check whether that checkpoint folder is already used by some other application or not. Okay, and this is an offset folder. Currently, nothing is there. And this is a source folder. So here we are fetching from one particular source. There is a path, given base path. So that's the reason we are saying under sources /0. Currently, nothing is there it to process the data. Now, let's see. Now, I'm adding the first file. So copying 1.json to temp folder of JSON 1.json. Now, this is an offset. So here, look at this application. Here, I'm not giving any trigger interval. If you're not giving any trigger interval, every 10 seconds, it will be polling for the source, and it will be checking whether there is any whether there is any new metadata is formed or not. That's how, after adding this file to copying this file to this particular location base path, application able to fetch the metadata information. That metadata information is going to this write ahead log folder, offsets folder. So this is a 0th batch. Whatever the numbering we see here, that numbering is directly like a batch numbers. If the first batch is fetching the metadata, it goes to the 0. It starts with 0, right? Batch ID starts with 0, so 0. Now, in this one, these are the basic configurations which are part of for this streaming application. This is a file-based source we are trying to understand. In this is an important parameter metric we have to check for. So it is showing log offset :0. We don't know what is 0, whether which file is actually it is going to process. For that, we need to go to sources /0/0. 0 is one particular source. Under this 0, whatever we are seeing, this is a batch ID, 0th batch ID. This 0 is equivalent to this 0 batch ID. And here we can see actually what is a path. This is a path information. And at this particular timestamp, it got loaded. And this is a batch ID information. This is for file-based source, we can see in this manner. Now, after processing that particular batch, so after processing this particular batch, it goes to the commits folder. So this is just try to understand, this is a offsets folder and this is a commits folder. Whatever batch you're processing, after committing that batch, it goes with the same numbering. Here it's a 0th batch, right? So here also it will be like a same 0th batch. And if there is any watermarking information, that watermarking information will be added over here. And this is, it's the same information, so you can ignore it. Sources file. Now let's go with a scenario 2, where here adding 2 files to the data source. So 2.json and 3.json we're adding to the this particular folder. And this is a information line Bangalore, Mumbai, and for 3.json contains Bangalore, Mumbai, and Amravati. So when it can, okay, now after adding that, now let's look at the write-ahead log. In the write-ahead log, offset of 1. This is a second batch, right? Because 2 files were added at the same time. So when it tries for the next poll, it identified that there is some metadata got changed. It got updated here, log offset :1. Now, when we go to sources/0/1, we can see 2 files got updated, 2.json and 3.json. Right? Now, after completion of that entire batch 1, we can see that information will be part of a commits /commits 1. Okay. Now we can see here the state information. Yeah, this is how it will be /0. This is a 0th state batch state information we can see here. So the state information in sense is a stateful operation. Let me show it. Here we are using the group by operation, right? So this belongs to the stateful operation. So over a period of time, we keep on accumulating that information, right? So that state goes to the this particular folder. Now this is a batch 0 folder information. Under batch 0, there will be 200 subfolders. Now, I mean, I'm talking about this one. Under 0, this 1, 2, 10, 100, 100, 100. We are seeing this one, right? This is because by default, the shuffle partitions is 200. That information will be part of a offsets folder. Yeah, by default, the shuffle partitions is 200. So that if 200 parallel tasks are performing at the same time, and the same information, that data task which is related to that particular piece of data, that goes to the subfolder under the state. Now, while processing the next batch, this state information will be used from 0, whatever the information which is part of this subfolder of 0. This is related to the previous 0th task, 1 task, and so on. So that information will be used. Okay. And when it comes to metadata, this metadata contains the information related to the data schema of that particular state store data frame. So this is whatever we saw so far, it is with respect to the file-based source. So okay, I can quickly go through this information as well. ID, this is related to the uniqueness of this particular stream, run ID. Within the streams, within the restarts, this run ID will change. Name within given, so it is giving as a null. Timestamp when this stream is started. Batch ID, this is batch edit. Currently, it's a 2 batch edit is trying to process. And input rows, nothing is there. Input row, so if nothing is there, then those will be 0. And duration ms, this, like for this particular batch, so what kind of operation took how many seconds, such kind of information will be part of this. State operators, as this say state related of this particular stream itself is a stateful operations containing, right? So that contains this metrics information, stateful related metrics. And sources, this is a file stream source. So this is a path, base path we are giving. And as part of this particular application, particular batch, how many, what is a starting offset and what is a end offset. In the batch 2, there is nothing is there. So it is just showing 1 and 1. And yeah, this latest offset, nothing is there. In the latest, currently nothing is there, right? So it is showing null as there is no information. So it is not processing in the as part of batch 2. It is just see, when there is a data, if there is a data, it will go on process that data, that metrics will be populated over here. Otherwise, every 10 seconds, it will poll for the metadata. In this case, it is trying to poll for the metadata. 0 and 1 batch is already processed. And next batch is batch 2, 0, 1, 2. And it is trying to poll for every 10 seconds. If nothing is there, then it will just publish the information. Whenever the data is available for the batch 2, then only we can see the real data. Until that time, it is just that it will show the dummy data like 0, 0. The latest offset is nothing but a fetching from the source. How much time it actually fetch to calculation of that metadata, for calculation of that latest offset. It's like a comparison from source metadata with a checkpoint metadata. This many milliseconds it took. Okay. Is it clear so far?
Yeah, I think so. If we go back actually to that, you're talking about the 115 milliseconds there. If that number was higher, what would that mean? Like if that was like a really high number?
So here there will be multiple aspects. So this is only for calculating the offset numbering. For as I mentioned, initially it goes to the write ahead logs, right? Now this is a 0, and there is another batch which was which processed 2 files, right, as part of here. So far we are having, this is the latest 2 batches got processed. Now this is like with respect to this checkpoint latest offset and comparing with the metadata source offset. So if there is no changes, then obviously it won't take much time. If there is a changes, then that whatever the processing we are taking, that information will be projected over here.
Oh, okay.
It all depends. Ideally, this will be taking lesser time for calculation of the metadata. It's just a calculation of metadata, right? Some metadata is already part of this offset folder, and the next metadata will be there in the new. Based on timestamp, it will be comparing. Till this timestamp, we are having these many files. We just need to, it tries to understand after this timestamp, what are the new files are available. If there is no new files, then just like that, it will give the information. Just how much that latest offset is just nothing but after this timestamp, how many new files are there. There is a new files, that information will be captured and it goes to the offset/2. If there is no new files, that's it. It will not be processed anything.
Okay, awesome. Thanks.
Yeah. Okay. I hope we are clear so far with respect to the file-based. Now, let's go with a Kafka-based source. So in case of file-based, we saw that there is information on file names, right? There is a file list. Okay. Sources, under sources, we can see the name of the file, one.json. Inside the offset /0, we're having a pointer, log offset :0, and the actual file name will be part of the source. Now, when it comes to the Kafka, it is slightly different implementation. Here, it is fetching from one source /0 /0. This 0 is representing the batch ID 0, the first batch. It starts with 0. Now, when you start the application, it is fetching this metadata. This is a Kafka topic information. EN is a Kafka topic. And inside this Kafka topic, this is a partition information. Inside this partition, from 0th offset, we need to fetch the data. This will be considered as a starting offset. So from 0th offset onwards, we need to fetch the data. Okay, that information used here. So at a high level, if you guys are not aware of Kafka, so Kafka is a message queue and like ecosystem terminologies. Inside Kafka, there will be a broker. Inside broker, there will be multiple partitions. So same set of data goes to the same topic. Just in a simpler terminologies, in case of RDBMS table, if it is a file based, just a file, same set of data will be there in the same file, right? So just similar terminologies. So now in case of Kafka, same set of data goes to the same topic. Now under topic, it will be divided into multiple partitions. In this case, for a simpler reason, we just going with a one particular partition. Under that partition, there will be offsets. Each row, each message goes to that topic. It will be part of a partitions. Under partition, there will be numbering. That numbering will be represented with offset number. Right? So this is a Kafka topic, and this is a partition, and this is an offset number. So in sources /0/0, we are going with the starting offset information. Now, in the offset folder, this is a starting information, right? Now, what is this one? This is like an end offset, till where we need to fetch the data. So it's like this is a starting, and whatever you see here, again, here also we can see the topic name, partition number, and this is a offset number. It means from 0 to 1419.825. It's like a -1 till 0 to till that my offset number will be fetching the data. After completion, it goes to the commits. It will be committed with the same numbering. Now, let's go with this. So it is, in this case, this is a broker details we are adding. These are cleaning up the previous checkpoint and the one of the data path. Reading stream with the format of Kafka. I'm passing the Kafka broker details. I'm subscribing to Kafka topic. And here, this is a starting offset. I'm using earliest option. If I'm using earliest option, then at that moment, whatever is the starting number in that partition, from that particular offset number, we are fetching the data. That is a significance for this earliest offset. Now, we are writing the data in the JSON format to this particular location. And this is a checkpoint. When we go through the batch metrics, it is processed until batch ID 110. And as part of this particular batch, these many records and these many input rows per second is this, and process rows per second is this. Here we can see more number of metrics. This is a batch add batch with respect to how much time it is taking for the processing and all those things. This is val commit and how much time it is actually taking time for committing, and latest offset, as I mentioned previously, understanding the metadata information and query planning. After fetching the data, after fetching the metadata, it will actually plan for that, how to do the query. It's a query plan, execution plan. How much time it took, 4 milliseconds, and overall trigger execution. The combination of other things just gives a trigger execution. Now, the major thing is with respect to the Kafka, we are subscribing to, you just need to look into these things. In this is a very simple operation, so we are not seeing any state operators. We are just fetching the data and writing to some destination in the file format. So there is no state operator. With respect to the sources, we can see the we are subscribing to this particular topic, and start offset. This is in this topic. This is start offset. The start offset we saw, right? This is a start offset from 0. At least this is a 1/10 batch, right? So here it's a different numbering. So from this number to this number, we have to fetch it -1. The end offset will not be fetching, actually. It's a -1. Okay. Now for the next item, so here for 1/10 batch, starting offset is this and end offset is this, right? For the 1/11th batch, starting offset is this 117957. From there, it will be fetching the data. Okay, so here also it will be the same 110. I mean 100 batches we are retaining. And yeah.
Hey, Vikas, we have a question. If we can get kind of a higher level explanation about the difference between like what a watermark is and how that is different than the checkpoint.
Okay, we will not be okay. With respect to the watermarking, just one sec. Okay, sorry. Sorry. Now let's discuss. So watermarking,
sorry, threw you off.
point, right? Okay, someone is pinging. Sorry for that. Okay, now watermarking will be using for the stateful operations. If you're not using watermarking, so if let's say if it is a stateful operation, drop duplicates, then like a deduplication operation. If one key is there, we'll be keeping that key over a period of, we'll be checking with all new batches and trying to understand whether this key already came as part of previous batches or not. Then we have to store this key as part of somewhere, right? So that if some data is storing over a period of batches, then we'll be considering as a stateful operation. That data will be used to process new set of batches. Now, let's say if you're not giving any watermark, this data will be keep on accumulating over a period of time, and this may cause the memory issues, right? To avoid that one, we came up with a watermarking. Watermarking is nothing but a limiting to some extent, okay, with over a period. Let's say if you want to limit only for 10 minutes, okay, then whatever the data is coming, we'll be storing only that last 10 minutes of data. Beyond that, we'll not be storing.
Oh, I see. So let me try to repeat this back to you using kind of a use case. So let's say we have customer transactions that are coming through, and we're trying to keep track of how many transactions have happened in the last minute or the last 5 minutes. So we would want a watermark that would be like 1 minute for if we're looking at the last minute, and 5 minutes if we're looking at the last 5 minutes of data. Does that?
Yeah.
Okay,
So this is only with respect to the stateful operation. To avoid the memory issues, we'll be going with the watermarking so that limited set of data will be keeping in our stateful operation. Otherwise, it will be keep on accumulating and it may lead to the memory issues. Now, till what time? We are only giving at a one time we'll be giving in the code. Okay, just go with the 10 minutes watermark. Then every time this watermarking timestamp needs to be upgraded, right? That information will be part of the commits. So somewhere we already saw. So here we saw this, right? This information. Currently it's a 0. If you're not giving any watermarking information, it will be 0. If you're giving any watermark, then while calculating, processing that batch, and finally it will be calculated what is our next watermark information, so that when it is processing next, that will be taken as a cutoff. That's how this will be updated. Is that clear?
yes.
Okay. Okay, here, yeah. So as I mentioned that it contains minimum batches to retain is 100 batches, right? So inside the checkpoint, it will contain only last 100 batches. So in this case, it starts from 11 and 111 up to here. The previous batches will be deleted. It means like whenever the new batch is going to add to this offset, immediately after that, the oldest batch will be deleting. Now look at this one. Here the offset 111 is calculated, right? Committing offsets for batch 111. And in the next, it is showing the deleting that particular path. Which path? The 10th. Oldest batch ID will be deleted. This is a batch ID in the sense file here that will be deleted. So at a time, 100 batches metadata information will be part of entire checkpoint. Either it's streaming, offsets, commits, or state, all these things. Okay. Now let's go to. Okay, fault tolerance. So now, while fetching the data, first what it will be doing. So we saw that there are multiple folders are there. It's a these are the folders: commits, metadata, sources. If there is a stateful operation, state. These are the folders we saw. Now, when you start the application, how it happens. Okay, when you restart the application, how it happens. Now it list out all the files which is part of a offset folder, and it will be listing all the files in the commit folder. From out of these two folders listing, it will be picking the latest offset file and latest commit file. It compares the latest numbers. If both numbers are same, then it is a matching scenario. In the sense, if whatever the data is processed, if it is stored in the destination, then if it is committed to checkpoint location, then the entire cycle is completed. That is a good scenario. Now, while processing certain batch, due to some issue, if my application is terminated, then there won't be any commit information, right? Commit information only happens after writing the data to the destination. If application is abruptly terminating, then there won't be any commit. Then it will be like this. So offset /3 will be there, and commits will be lesser than offset. In this case, everything will be listed. This is a latest offset, and this is a latest commit, and it is not matching. Latest offset is greater than 2. Now, when you start the application with the in this scenario, for the next step, when you start the application, it goes list out all the latest offset, latest commit, and it will try to compare. In this case, it is 3 is greater than 2. it means that while processing the previous batch, application got terminated, then framework will consider that I need to reprocess the metadata of 3. So this is how we are achieving the fault tolerance. Wherever we stopped, we are trying to process that. If it is a good scenario in the restart, now same process, it will be listing offset folder, fetching the latest offset, fetching the latest commit. Now, if both are considered as matches, then whatever data is processing previously got processed and committed successfully. So I need to freshly get the metadata from the source. That is a positive scenario. If it is not matching, it's a negative scenario. In a positive scenario, we'll be fetching the new metadata from the source. In the negative scenario, we'll be reprocessing the previous val file metadata information. Now, let's understand this with respect to the logs. So this is a file-based logs. So in this case, it is listing the offset numbering 0, 0,1, and it is identifying latest is 1. And in case of this is listing only 0 it is showing. So only 0. This is the latest. Now query should start from 1. Look at this one. Query is starting from resume batch 1, because while processing the previous batch, it got terminated. So when you restart the application, it needs to process this batch first before fetching the data from the source. Now, this is with respect to the Kafka source. So in Kafka source, first 8 batches got processed. Okay, this is a latest 7th, and this is a listing. It is giving as a 6th. So till 7 batches, 0 to 6, 7 batches got successfully processed and committed. But while processing the 8th batch, it got terminated. So 7 is greater than 6. It will be considering to reprocess from 7th batch on. So 8th batch onwards, from 7th batch ID, assuming it batch 7. Batch 7 instance, it starts from 0 to 7, right? So officially it's 8th. So yeah, these are the metadata which is part of this particular val file. From there, it will be fetching the data. Okay, so we discussed on good scenario and negative scenario, right? Now, usually we'll see a lot of questions on this one. How applications will work with respect to checkpoint after restarting the application with a new starting offset. Now, application got running, and let's say if they terminated the application. Now, if I want to fetch the data from certain position onwards from the source, if I'm changing the earliest of, if I'm changing, adding this, something like this as the earliest, or adding like a latest or some other value, there are many options from this particular partition. There are a couple of options out there to fetch it from specific information. If you're restarting the application with the same checkpoint, then it will not be considering any of this. The starting offset, earliest or latest, this will be only considered when we start at a first time. When you restarting application at some after some moment, then it will not be considering any of this. It will be just going to offset folder, commit folder, and repeat the same activity. If it is comparing both are same, then it will be fetching the new metadata. If it is not comparing, offset folder batch ID is lesser than the commit folder batch ID, then it will be processing this one. So please remember this one. This will not be having any significance if you're restarting with the same checkpoint. So now let's discuss this part. This is fault tolerance with respect to the Kafka source to file sync. So data returned to sync, but not committed. So now let's say whatever the data is processed, that data is returned to the sync. But before committing that information, it got terminated. Okay. Now this is a scenario use case. Before committing, it got terminated. Now, as per our logic, so in this scenario, again, it will be listing both latest number, latest offset folder number, and latest commit folder number. If it is not previously committed, obviously the previous, it will not be matching, right? Latest offset folder number and commit folder number will not be matching. Then in that case, it will be reprocessing the same data. Whether it will be really reprocessing the data, that we need to understand. Okay. So if it is, let's say, if it is reprocessing, then it will be generating a duplicate data in the destination. Okay. So let's try to understand this part, how it works. So here, these are the reproduce steps. So I hope you understand the scenario, right? I'm just repeating once again. So I'm fetching the data from Kafka. I need to write the data to one particular file in a JSON format. So data is returned to the destination, but before committing, I need to, that application got terminated. So for this, I need to reproduce it. So here, I'm going with the trigger once. I'm just loading one particular batch. So if it is a trigger once, only one particular batch will be processed and it will be committed. So after committing that information, I'm just removing that log, the latest file in that commit folder, and rerunning the same application. And let's check the behavior. So when you look at here, this is a simple application fetching the data from the Kafka source and writing the data to this particular location with a trigger once. Trigger once means it will only process one particular batch. So in the offset folder, I can see one particular, this is a 0, only one batch we are fetching, and the same we are committing. So it's clean so far. Now, in case of file-based sync, that information goes to the commit in, if we are writing to file-based sync, there will be, this is the actual base path we given. Under this base path, there will be another folder called _spark_metadata/0. Under this base, under this folder, we'll be actually creating one particular file name with the same batch ID as this. Under that one, it will be giving information related to actual files. It's like a pointers to the real actual files, right? You can see it here. This is a base path. This is a folder. Under this folder, we are creating a 0 file. And yeah, this is the actual file. That is what is part of this /0. Okay. Okay. And this is just an information, how many offsets we read as part of one particular trigger one particular batch, till how many offsets we read. So this is a last offset number 334403. Okay. Now, this is a good scenario where everything is committed, right? Now, we need to reproduce the same, reproduce for the use case. I'm just removing the first batch from the commits. Here, I'm just removing from the commits. Now, when you open it, when framework tries to list out, in the offset, there is a 0, but in the commits, nothing will be there, right? Here it is showing nothing is there because we already removed it. So this is what our scenario is. When you say Kafka to file source is a fault tolerance, how we are achieving, we are trying to understand. Now I'm restarting the application. If you restart the application, so in the framework, it will be listing. Here it's a 0. And in the commit log, there is nothing. So ideally resuming at batch 0. So it is trying to reprocess the same batch 0 metadata. So now it is reprocessed. I mean, it is showing us committed. Now let's identify the actual data, what it got processed. So as part of sources, it starts from 0. And this is a offset /0, 334404. So -1 till -1, it will be actually processed the data. Now, when you look at here, it's the same. This is a batch 1. So under 0 only we are seeing. This is a set. This is a file, the same file. This is a file. So when you look at the actual data, it is actual data of the offset till where the offset is actually fetched. It is just showing 334403. When you look at here, before reproducing, it is also showing 334403. Then the question is whether this is here as per the logs, as per the framework, it is showing as resuming at batch 0. If it is really resuming, then ideally it should be reprocessing the same data and more number of records should be there. More number of records should be there. Duplicate records should be there, right? But it is not actually. We don't see any duplicates in these offsets. See, there is no duplicates. So this is a here in the framework. It is trying to compare with a batch ID of whatever we are trying to process. That batch ID with a with that particular folder. Under this particular folder, this batch ID, the latest batch ID. If it is already there, then we will be skipping that one. So it will be identify that, okay, I committed the data to the destination, but unfortunately, before committing to the source or committing to the checkpoint, the previous application got disconnected. So that's the reason it will just go with, it will not reprocess the same data and it will just commit the information in the checkpoint. Okay. So what it is doing, it is comparing the batch ID information with respect to the latest of batch ID here. This is with respect to Kafka source to file sync. We understood how fault tolerance happening. Now let's go with it, Kafka source to Delta sync. So it's the same way we are trying to understand the data is written to the Delta sync. We are fetching the data from the Kafka source and writing to some Delta location with the Delta format. And this is checkpoint. So after writing the data to the Delta table, we need to remove the commit. I mean, ideal scenario is after writing the data to the Delta commit, application got terminated. Just to reproduce it, we are just trying to remove the first batch commit log. Okay, let's go quickly. So here, so fetching the data and writing to this location. And yeah, we can see this is a destination Delta path. Here we can see there is a data. And in the commits and offsets, it's perfectly written. And we can see describe history, version 0 is created. And in the offset, it got loaded up to this particular number -1. So we can see 0 to this particular number. It's -1 of this. This is equivalent. And that's what we are seeing here. Now to repro this our use case, we are removing the commit log. We are removing the latest commit log. This is a 1, 0 we are removing and restarting the application. If you're restarting the application, it needs to reprocess the same data because it will be comparing the zero will be there. Zero will be there in the offsets, but it is not committed because we removed it. Then it needs to refetch it, right? So now this is a trigger once it is whatever the data is processed, it got committed. And in the offset, we are seeing 343459. It is same as 34349 because it needs to reprocess the same offset. Now, strangely, when you look at the history, describe history, we are not seeing the second version. Commit version, we are not seeing it. We are only seeing one commit version, right? So it means that it is not reprocessed the data. We also checked it, the max offset. The max offset here, this is the one. And we also checked the duplicates. There is no duplicates. Now the thing is, it is trying to identify with a batch ID, with a epoch ID. Okay, when you look at here, this is a trick here. Framework will try to match epoch ID 0 with a batch ID. If the framework, if the batch ID is already loaded, then obviously if it is matching, then it will be skipping this information to reprocess. It will not be reprocess. It will be skipping that particular epoch ID. Okay, that's how we are not seeing the second version for this. That's how we are achieving the fault tolerance with respect to the delta sync. In case of delta sync, we are going with a matching with respect to the epoch ID and our batch ID. In case of file-based sync, we are matching with the underscore spark metadata, underscore spark metadata / the latest file. Based on that, we are trying to match. So that's how with respect to the fault tolerance. So when you start the application, processing certain application, and suddenly if you feel that, okay, I need to change few things to the application, whether it's a valid or not. So there is a big list of changes, whether we need to do or not. There are do's and don'ts. So few changes are allowed, few changes are not allowed. It is part of this particular reference link. We can send it later. So we have to be a little cautious on that, which changes are allowed and which changes are not allowed. As per that, we have to add it. Otherwise, we need to delete the checkpoint and go with a fresh checkpoint. So Kafka performance improvement option. So by default, so in case of Kafka, if I'm having, as I mentioned in Kafka, there will be topic and multiple partitions, right? Now, if I'm fetching the data from streaming application, it's like a 1:1. If I'm having one core will fetch the data from one particular partition. So one particular Kafka topic is to one task or one core. Okay. So now how can I improve the performance? Now let's say the current problems. If I'm having 4 partitions, I'm having more number of executor cores. If I'm having only 4 partitions and let's say 10 cores, then only 4 connections will be established and rest 6 cores are idle. So rather than that, if all cores are utilizing, that will give better performance, right? So for that one, the min partitions is an option. If you're going with the min partitions, whatever the number we are specifying that the main requirement is more number of cores should be there than the number of Kafka partitions. This cores in the sense executor cores I'm talking about. If 4 Kafka partitions and I'm having 10 executor cores, then if I'm giving min partitions as 10, then this 10 cores will virtually split the data in the 4 Kafka partitions and fetch the data as a 10 task parallelly. That will give a better performance. Let's go with this. So in this example, This is a basic scenario where I'm fetching the data and writing to certain destination in the trigger once. Here I'm fetching num input rows as 62500. These many rows are fetching and it is taking this much of time, 4317. So as I mentioned here, this is a 1:1. In this example, in EN topic, there is only one partition. So as per the framework, it is only fetching from one partition. So only one task is launching. And here, the main thing you have to concentrate is num input rows, totally 62,500, and it is taking these many milliseconds, 4,300 milliseconds roughly. Now, the config is min partitions. If I'm adding min partitions as 5, so now to process 62,692, it just took 2,842 milliseconds. So here 4,317 milliseconds it reduced to 2,842 milliseconds. That is because of splitting that one partition into virtually into multiple partitions. That multiple partition number, that is what we are specifying here, number 5. This number is equivalent to the number of cores which is available in the executor. We can give as many number of executor cores. With the more parallelism, we are getting a better performance. Okay, it's already 6. I'll just quickly complete this one. Okay, one edge case scenario we'll be discussing. Let's go with what is max offsets per trigger. Now, let's say I'm having a huge data. Then if I'm processing for the first time, let's go with the Kafka source. If I'm processing for the first time, then within that particular batch, it will be fetching entire data in a single batch. Now, to process a huge data in a single batch, the problem number 1 is we should have enough number of resources like CPU, memory to hold this much of data to process it. If there is no that much of resources, then the problem is it leads to the memory issues, and it may lead to the failure, executor loss failure. So to avoid that scenario, we can go with a max offsets per trigger. So it will be limiting the number of rows to fetch, messages to fetch from the source. So this is rate limit. It's like a rate limit. Now I'll be limiting the number of rows. Okay, so if I'm limiting the number of rows, then I'll be only processing certain number of records as part of this particular batch. Then that is, if there is limited resources, then it is good. It's better to go with this configuration. So there won't be any issues with respect to the resources. That's a main reason we are going with a max offsets per trigger. Okay. Now, let's say my batch is, my application, streaming application is processing for the first time. Or whether it's a first time or it is processing for over a period of time. Now I want to change the, increase the load, either increasing the max offsets, either increasing the number or decreasing the number. It can be anything. Okay, how to, whether it will really process the same number of records. If I change it immediately, whether it will process. In the sense, now application is running. Now I'll be terminating that application and changing this offset, max offsets per trigger value. Either I'm adding newly or I'm changing, increasing or decreasing the value in both scenarios. Okay. Now, when you restart the application, how it works. So as I mentioned, when you restart the application, okay, it goes back to the original framework logic. It will be listing offset folder latest value and commit folder latest value. And based on that, it will be processing. If offset latest value is greater than the commits latest value, then offset latest value will be reprocessed, right? So when you stop it in the previous job, while running the application, when you stop it previous job, at that time, let's say if my if my offset folder is already loaded, then even though when you restart the application with a new max offset per trigger value, it will not be considered for that particular immediate run, because this is a logic in this because this is a logic where framework will goes to the checkpoint and it will try to compare. In this case, 5 is already there while terminating the previous application. Framework will consider that to process this 5 first. Okay, now if it is processing the file, same file, then it is not considering this latest value, right? Max offset per value will not be considered. So for that one, we have to remove this. We have to, when you're changing this max offsets per trigger, you have to remove this checkpoint latest file name number. And when you process it, if you're removing this one, then 4 will be there. If both are matching, then now application will be fetching from the source. When application will be fetching from the source, first it fetches the metadata. Metadata will be calculated based on max offsets per trigger. Now let's say even I'm having 1 million records to process. If my max offsets is just 1 lakh, it will be processed by only first 1 lakh records. Okay, so to handle this, there is a code. Usually it will be identifying what is the latest commit, and based on that latest commit, it will be fetching that particular batch ID, and it will be purging that particular batch ID, purging that particular offset file. Quickly, I can go through this. So this is a file. So now, so here I'm not giving any max offsets per trigger. Now here it's processed 2 batches. I terminated this application while processing the 3rd batch. Okay. Here I didn't pass any max offset per trigger. Now I want to process I add the max offsets per trigger as 50,000 value with the same checkpoint, not changing the checkpoint. Now, when you look at this, so expectation is when you change the max offsets per trigger after restarting, it should process for 50 records. But when you go and check it, it is processing, the previous batch got processed 1 lakh records. Okay, this previous batch got processed 1 lakh records, but we given 50. But why? The reason is when framework will go to this, when you restart, framework goes to this, it will be listing, identify latest, it understand that 2 is not processed, so it will be processed that. So as part of 2, it is, when you look at here, as part of 2, it should process until this offset. What is a starting offset? The previous offset was a starting offset from 2 lakh to 3 lakh minus 1. Till that offset, it needs to process. Okay, so that is the reason it is going with a 1 lakh. Now, let's, okay, this is a 1, right? Now, let's go with this. Now, identifying the what is a compare when you this particular code will try to fetch the latest commit and will be purging offset files after this commit. Okay, so in this case, it will be purging 4. So just go with this. Okay, so here, so in this example, it's the same continuation of that one example. So this already 50,000 is there. So when you look at here, offset 0 to 5, 0 to 4. So here, while processing the 6th batch ID number 5. sixth batch. It got terminated. Now the ideal scenario is we need to delete this particular offset file. This particular offset file, we have to delete it, right? So this code is identified. The last commit is 4. So just purge the files after 4. So this is a file which is there after 4. So we are purging this file, right? So that is what happened. So now when you look at here, both are 4. Now I'm changing the max offsets to 100. Now, if both are 4, framework will consider both are equivalent. Then as per that, okay, why till previous batch, everything got processed and committed. I need to fetch the new batch. So whenever you're fetching for the new batch, then only it will be considered this max offsets per trigger. Now, when you look at here, you can see the 6th batch is processed with 100 records. Yeah. Okay. Yeah, that's it from my side. Do you guys having any questions?